All right, guys, good afternoon. The first session is about evidence-based planning. Harry introduced the topic last week, so we're going to look at it in a little bit more detail. And then we will have a couple of presentations from Athens, either PhD students or recent graduates. So it's just going to be a couple of short presentations about PhD research. And finally, we will have a lecture from our partners, Noumena in Spain. Evidence-based planning. I'm going to give a brief introduction about it. I'm going to talk about theories and methods of evidence-based urban design, urban planning, although really I'm going to focus on one method called space syntax. And I hope to have the time. I'll show you definitely at least one case study, maybe a little bit more depending on the timing. So the first question is, what is evidence? It's a question for you. What do you think evidence is? In Athens as well, if you want. What constitutes a fact? And you can say in Greek. We don't know. Okay, let's talk about the definition of evidence-based design then, and then we'll look in a little bit more detail about evidence itself. The concept of evidence-based design actually comes from the field of healthcare design, so the design and architecture of hospitals, essentially. And this is because at some point in the past, someone did a big piece of research and realized that the design of hospitals actually determines the health outcomes of patients inside the hospital. That means recovery time, how well they recover, and so on. So the Center for Health Design definition of evidence-based design is the process of basing decisions about the built environment on credible research to achieve the best possible outcomes. In their cases, health outcomes that they're talking about. The definition was expanded towards urban design and planning to apply to the whole of the design field. And basically, this means that it's design and planning that involves using empirical evidence to inform decision-making through the process of design and planning. So it emphasizes relying, basing decisions on the best available scientific evidence, rather than design ideas, design tradition, intuition, or personal experiences of the environment. The goal of evidence-based design and planning is to achieve the best possible outcomes by incorporating credible research in the decision-making process for the built environment. What I want to stress here is that evidence-based design is not just about basing decision on evidence. So you might know that trees are good for you, and you'll put a lot of trees in your design. You might know that good lighting is good for you, and you put a lot of windows in your design. That is part of it. But what evidence-based design and planning does is actually to test the design before it is implemented. I think that is really the fundamental thing. And what you can do with it is to test a lot of different design options to know which might be the optimal one based on what you want to achieve. So it's a deliberate attempt to base decisions on the best available research evidence. And it includes an evidence-based designer together with a client and other stakeholders making decisions based on research and also based on project evaluations. So based on evidence resulting from analyzing the impact of previous projects that have already been built and how they function and how they work. So what you actually get, this is one conceptual model of evidence-based design and planning. There are a few, but what this one highlights is that it takes into account 3 different types of knowledge. One comes from scientific research, essentially from us, from academia. One comes from the user experience, what the user needs, what the users need, what they want, and so on. And the other is professional know-how, so the experience of practitioners and designers from previous projects. And this tells you actually that evidence can include a lot of things. So it's a wide range of sources of knowledge, which might go from literature reviews, systematic literature reviews, to planning and design guidelines and expert opinions as well. How does this, what does this mean, having this range of evidences? So it goes from very casual pieces of information. I noticed this, I noticed that. Someone tells you, oh, this space is nice or this space is bad. To more applied types of knowledge. So this tends to be the practitioners' knowledge and what they tend to do normally, often in the design process, which is site analysis before designing, and so on. So it comes from practice, and then it goes into more developed expertise, whether it's from professionals or academics, up to what is considered the most rigorous research evidence. So in fields of very hard science, like medicine, these would include randomized controlled trials, checking whether a medicine actually works or not. It is harder to achieve this really hard evidence in urban design and planning because we always work in the real environment, and that means we cannot test things in a laboratory. We cannot actually build a city in a laboratory to control for every possible thing that might happen. But this just gives you an idea of the range. So it includes data generated from non-scientific means, but also very hard data. And how do you deal with it? This is the difficult thing with evidence-based design. You have to, when you look at the evidence, you collect data and information to create a design. You have to evaluate what is important, what makes sense for the specific design, what is the strongest evidence. Are there very, very many studies that show that this will happen if I design it this way, or is it just one? So basically, you have to make a value judgment ultimately. So the idea is that EBDP is important because it helps addressing complex challenges, and it helps creating built environments that, I would say in simple words, that actually work, that do what you want them to do. So the idea is that when you design, you're trying to achieve, so you have a goal, you want your design to be able to do something, and you test it so that you minimize the risk of undesirable outcomes. Why do we do this? It's because mistakes when we build things are very, very costly. It depends where you make the mistake, but a building tends to last without intervention for about 60 years. If you build the roads, they last almost practically forever. They're very, very hard to undo, and actually digging up a road and making it is extraordinarily expensive. So what you want to do is to make sure that what you're designing is actually going to work as you want it to. So this is a summary. So it emphasizes the use of scientific research, empirical evidence, and analytical methods. Bear this in mind for later, the analytical methods. What do you do in practice during the design process to inform your decisions? I just want to show the difference basically between a linear design process and an evidence-based design process. What it is, the main difference in the evidence-based design process is that it's a lot more circular. So you start with a question, you do research about the evidence, that might give you information, you analyze the design, and then you create a design proposal. And then you test it and you revise it. So taking a step back, how does the design process start? So normally, design ideas begin with an intuition, really, and that is often what we are taught to do in design courses in architecture, is working with a concept. The light bulb comes on and you go, it would be great to do this. But basically you have a conjecture. You think this is might be a good idea, you test it, and then you revise your initial idea. In the evidence-based design process, then you move on and you analyze your design and you refine it, and you do this in a circular way. So it goes from conjecture and testing to analyzing and synthesizing the findings from your testing to then develop a design solution. Going step by step. So this is essentially a generic urban design process. This is what practically everyone does as a first step. There are two main stages of design generation. One is design generation and one is design development. And basically they create a cycle. You have a brief as a designer. You take into account probably some wider urban issues. And you might even do participation, stakeholder consultation, and so on. So you develop a solution and then an output, which normally comes after the design development phase. But you can repeat this process before you actually create the output. Then we move on to what we call an analytical design process, an analytical urban design process. And here you have an analytical phase to start with. So you still have a brief, as you do as designers, as practitioners. And before you start generating ideas, you actually do an analytical phase, a baseline analysis. You analyze your site, the surrounding area, and so on. Only at that point, you go into the design generation phase. The previous elements are still there. Did you want to ask something? The previous elements are still there, so you still take into account the wider urban issues. You still have stakeholder engagement. And then the analytical tools are actually applied after the formation of a design idea or a design options or multiple design options to evaluate them, create a design solution, and then feeding back into the process. Again, it's circular until you're satisfied with the solution and you create the output. Then what we actually prefer, and by we, I mean advocates of evidence-based design, especially those who do spatial planning, it's what we call a spatial approach or a configurational approach to urban design. So in this one, the basis of the analytical study, the baseline study before you even start generating ideas, is the evaluation of a spatial configuration of the urban environment. So you look at how the spaces, the street network, or the site, if you're working on a building, actually perform before you start designing. Now, you can do this, say if you're redesigning an existing building, you can do the same. If you're designing a brand new building, of course, you can only do this with regards to the site and the surrounding environment. But the spatial analysis can be applied at the building level and at the urban level as well. Then you go through the same process that was described in the previous diagram, the analytical analysis. And you start evaluating your design spatially as well as with other methods. And this is something that Ed showed last week, where he's layering other pieces of information and data like land use or population density or health outcomes on top of a spatial layer. And this is done to enhance the ability of evidence-based design to respond to different questions, because your initial question might be, is this design good for the environment, or is this design good for health, or is it good for the economy, and so on. So it depends what you want to answer, that you're going to have different types of data. Now, I will introduce specifically a methodology, space syntax methodology, which is a spatial analysis tool. Has anyone here heard of space syntax before? Maybe from Nadia or in other courses, except for the front row here. Okay. I mean, obviously, Ed mentioned it last week, so you heard it last week. But space syntax is a theory, but for our purposes now, let's say there is a set of techniques for analyzing urban environments, spatial layouts, so buildings or urban environments. And it analyzes environments in relation to human activity patterns. So how humans, how people use space. So it links space with society. And it's based on the idea that how we perceive the environment is linked to where we are in it. So as we move through space, what we actually see in front of us changes. And so we have things like movement, which is linear in space. And we have things like interaction in space, which is a static activity. So movement tends to always takes place in a linear way, and in those elements of the environment which tend to be linear, like streets or corridors. Of course, we also move across convex spaces, across squares or across rooms, but it tends to be in spaces which geometrically resemble squares or circles, convex spaces where interaction tends to take place. So based on these, the researchers who developed space syntax methods create tools that are able to measure these characteristics of space. So they take geometrical attributes of space, and here we have the example of a building, of a layout of spaces, and it's considered as a network. So it's a network of rooms linked to each other by doors or corridors, and this network is measured as a pattern of relationships or a graph. So depending on the space you're in, how you understand and read the rest of the environment, whether it's the city or a building or an apartment, depends on where you are. So if you look at the graphs at the bottom of a building, they all represent the same building with the same links. But they look very, very different because they start from different points in the building. So the first one is if you are in the Grand Salle, then to say reach the last space, the farthest space away from you, you see the diagram of spaces through which you have to move to get there. If you're in the Salle commune, the graph is different, and you can see that is a lot more shallow. The first one is a lot deeper. If you are from the outside of the building, you also have a different type of graph, and this tells you how the internal layout of the building relates to the outdoor space. Now, these are then measured quantitatively. They give a value to every node in this graph, and they measure different things. Most of these measures are based on the depth of spaces, so how far things are from each other, depending on where you are. So the output of the analysis is shown as a range of colors. In this case, I'm giving the example of an urban environment. The colors in classic depictions go from dark red, the most connected or integrated spaces in the system, to dark blue, which are the most segregated, the deepest spaces in the systems. So the network of all public spaces, in this case is all the streets and all the public spaces in a city, are represented within a single model. And this model corresponds to how the street network or the layout of a building is perceived by the user. And also how it is used by the user in terms of movement or in terms of static activity. So this is a very well-established spatial methodology to understand design, urban environments, and building layouts. And I think that's all I want to tell you about space syntax, and I will show you case studies using this methodology. If you want to know a little bit more. There are just some references here. The two key publications about this topic are the Sociological Space and Space is the Machine, but there are also links to some simpler resources which tell you about definitions, practical examples, and so on. Let's see, I've still got time for more than one case study, I think. And I will go through this quite fast because Ed also showed it last week. And this is Trafalgar Square in London. The first image on the left shows the space syntax analysis of the square as it was in the 1990s, until the 1990s. What they did, the company Space Syntax Limited did, was to analyze the proposed design with the method. So they got the drawings. This was by Foster and Partners. The road at the northern end of the square was pedestrianized. This is why you get so many lines through it, because the model is no longer just following the pavements at the end. And this is a high resolution model. So you have a line on each side of the road where there is a pavement and a line through pedestrian crossings as well. The reason why they wanted to redesign Trafalgar Square was because it was very badly used, in the sense that very few people actually got to the middle of the square and not many people spent time there. So the design was implemented, and afterwards they did observations. They actually did observations before as well to understand how people were using the square. But here I'm only showing the outcome, and the result was that people used many more different routes to access the middle of the square, and a lot of people actually spent time there right in the middle of the square and the stairwell that was built on the northern end. Another case study. They're all from the same company, Ed's company that you saw it last week, Nottingham Market Square. The image on the left is the resulting outcome, and this was an award-winning square. It's very, very well used nowadays. It wasn't before. And what they did was a visibility graph analysis. So there in the central space, you have a central space, which is a convex space, and then you see the roads branching out from the square. The visibility analysis is similar to the urban analysis that I showed, meaning that the red color are the most accessible areas in the square. And there are some really strong diagonals there. And when you have these high visual accessibility, it tends to be where people prefer to walk. It makes it, they become people's preferred route because of the way they perceive the space, because they can see more from there and they can see where they're going. So they did a pedestrian movement survey, and despite the fact that there were this diagonal in the layout of the square without taking into consideration any urban infrastructure, they realized that pedestrian movement was very, very low in the middle of the square. And this was because most of the square was surrounded by major roads. So even if it might have been desirable for people to go across, they were forced by traffic and the way the crossings were designed to move around the square. They did another couple of types of observations. One had to do with diagonal movement. Let me get my laser pointer for the people in Athens. So for you as well. So they looked at how people that went, that had to move diagonally, meaning from corner to corner of the square, say from here to here or from here to there, moved. And they realized that despite perhaps bad crossing design, a lot of people still went through the center because it was the most desirable line. But still 30% of diagonal movement actually avoided the center and they had to go round the square rather than across. This was just for diagonal movement, but for all movement in general, the great majority of movement never actually went through the middle of the square. So what they did this design which pedestrianized this side of the road. This end in front of the church was already pedestrianized. They pedestrianized the long end and they created this diagonal across the square, a long diagonal and a shorter one, which you can see actually correspond to these two diagonals of high visibility. And that is the result, basically. And now most people actually move along those diagonals in the square. Finally, and very briefly, a final case study. And this is just to show you how the urban model works in practice. This is Princess Circus in London. And so this is New Oxford Street, if you know the area, if you know London. Covent Garden is down here. They modeled the existing situation. Again, this is a high resolution model, mapping both sides of the streets and the pedestrian crossings. They got a design. I don't actually remember who this one was by. Or maybe they, no, I think they might have done this themselves, actually. And then they remodeled this design. And as you can see, the lines connecting the north to the south become a lot more integrated and a lot more accessible in both, across both diagonals. So the idea originally, they wanted to address this area because it seemed that the British Museum is right here in the north of this area, and Covent Garden is here, and it's about a 5 minutes walk from the edge of Covent Garden to the British Museum, but they realized that nobody walked there, and that was because they weren't really well connected and people didn't realize how near they were to each other. So this is how the model tells you whether things are improving or not. If you did another design, it might be that actually it might have become more segregated, so you less accessible, and you would have discarded the design. This was not actually implemented. There was a redesign of the area, but it was sort of a compromise. So this is not actually in place as it was designed by them, if you happen to go there and check it out. So that's all from me.